Hi everyone. In this section, chapter 10.2, I'm going to explain about inferences for two population means using independent samples. So throughout this chapter, we are considering independent samples. We assume that standard deviations are equal. So throughout this section 10.2, we assume that standard deviations are equal. So let's move to the section. In this section, we are going to compare two population means when the two samples are independent. This is really important. We are considering two independent samples. So here you can see the assumptions what we are considering in this section. First assumption is standard deviation of population 1 and population 2, which mean two different populations, they are equal. Okay, but standard deviation unknown. Their standard deviations are equal, but we don't know what is the standard deviation. Okay. Next assumption is populations are normal distributed. We assume that populations are normally distributed, so that already samples are normally distributed. Okay, first our hypothesis. Oh sorry, I don't know why we can. Okay, this is gonna be mu1. Always null hypothesis we consider mu1 equals mu2. This is our null hypothesis. Okay, and other hypothesis mean alternative hypothesis can be mu1 not equal mu2, or mu1 greater than mu2, or it can be mu1 less than mu2. These are the other alternative hypothesis. It can be only one at a time. So all null hypothesis always mu1 equals mu2. So you don't have to worry about the null hypothesis. Always we consider they are equal. Okay. Okay. This is our test statistics. So you know that if we need to calculate the if you need to check the inference, so we have only two approach, critical value approach or p-value approach, to get the results from either p-value approach or critical value approach. We need to find the test statistic and alpha, which is a critical value. So this is the standardized version of what we are going to find. This is our term x1 bar minus x2, difference of the we are dealing with distribution of x1 bar minus x2. So this is when we this is how we standardize it. We call it capital X. We did this in our last chapter, chapter 10.1, standardized version. And standard deviation, if we need to talk about standard deviation of two populations, we assume that they are equal, but we don't know. Okay, so simply you can plug the standard deviation into this equation and you will get this. You can simplify like this. Okay, but sigma unknown. Okay, since the population standard deviation sigma is unknown, we have to estimate the standard deviation. So we estimate this standard deviation and we call that pooled sample standard deviation. Pooled sample standard deviation. It is just a name. So we denote it by S sub P. S sub P. P mean pooled. So this is the formula to calculate pooled sample variance. Pooled sample standard deviation. N1 is the first sample size, N2 is the second sample size, S1 is the sample standard, first sample standard deviation, S2 is the second sample standard deviation. So by using this formula you can find the SP value. SP means pool sample standard deviation. Okay. So now we can replace the sigma with pool sample standard deviation. So whenever we get the pool sample standard deviation, because we don't know the sigma, we have to consider t-test. Because sigma unknown cases, we use t-test instead of c-test. Okay. So we have to come back t from c. Okay. So now test statistic is t. Okay, t. So formula is exactly same what we saw last time. T equals x1 bar, it should be bar here, x1 bar minus x2 bar minus mu1 minus mu2, okay, divided by sp. Now sigma replaced by sp, square root 1 over n1 plus 1 over n2. Since we are using t-test, we need degree of freedom. This is degree of freedom, df. We denote by degree of freedom, d naught. n1 plus n2 minus 2. This is the standard way how we find the degree of freedom. Okay. If you need to find a value from the t table, you should have two things. It is alpha and this degree of freedom. It doesn't matter if you switch this order, it's fine. You need to have the alpha, which means significance level or significance value, and degree of freedom. This is the degree of freedom. Okay. So on null hypothesis, you know that mu1 equals mu2, which means they are equal. So simply you can get it, you can simply remove this mu1 minus mu2 term because it is equals to 0. Okay. So you can see here now t equals x1 bar minus x2 bar divided by sp times square root of 1 over n1 plus 1 over n2. Okay. Okay, pool t-test. We call this pool t-test because we are using pool standard deviation. In this case, we have few assumptions. We are considering simple random sample, independent. They are independent. These sample, first sample and second sample, they are independent. Normal distributed population. Populations are normal distributed, or we have large enough samples, which means n greater than or equal 30, something like that. So we can approximate this normal distributed. Then we assume that standard deviations from the equal populations. So we assume that we have equal populations. So we have standard deviation from equal populations. Clear? Which means capital N1 equals N2. If we have N1 and N2 populations, N1 equals N2. So again, test statistic is this one because we are considering our null hypothesis mu1 equals mu2 case. Okay. Okay. I told you we have two approaches to find this inference. First one is critical value approach, the other one is p-value approach. So let's see how we deal with this critical value approach first. First of all, you have to state the null hypothesis and alternative hypothesis, decide what is the significant level alpha they will give you, so no problem with that. Compute the test statistic, which means this one. Okay, you already know what is the test statistic. You have to calculate this test statistic. Next, find the critical value T alpha. You have to find the critical value T alpha, this value. T alpha using the T table. Degree of freedom always n1 plus n2 minus 2 with the given significant level. Okay, alpha is given. Okay, let's try. If left tail test, then we have to find negative T alpha. Remember that this T table is symmetric. Okay, same as Z table, it is symmetric because we are taking standardized version. So we reject if negative T alpha greater than T value. Okay, negative T alpha means the critical value. So our critical value greater than T value. So our negative critical value, okay, negative T alpha greater than T value. So what we're gonna do? We have to reject. Okay, if it's a right tail test, which means we reject if our T value greater than T alpha, T value greater than T alpha, which means simply it is in the rejection region. Our critical value, it's in the rejection region. Okay, if we have two tail test, then we have to reject if T greater than T alpha over 2 or T greater than T alpha over 2 or T less than negative T alpha over 2. Okay, so you don't have to worry about that. We reject, in any case we reject if our critical value within the rejection region. Okay, okay, next p-value approach. For the p-value approach, first few steps are similar to a critical value approach. State the null hypothesis and alternative hypothesis, decide the significant level alpha, compute the test statistic by using this formula, then find the p-value using T table. We already know that degree of freedom is this one, df equal n1 plus n2 minus 2, and calculate the test statistic. Okay, okay, same here, we have left tail test with the p-value. So left tail test mean here p-value within the rejection region, so less than T. Right tail test, our p-value greater than T in this side, right hand side, and two tail test, p-value with we mention within these two sided, which mean p-value equals 2 times that table value. Okay, so it doesn't matter, we reject our null hypothesis if this p-value less than alpha, which mean we reject our null hypothesis if our p-value within the rejection region. This red color region is the rejection region. Okay, let's see this example. We have 11 male and 11 female students, and significant level is 10%, which means alpha equals, it is 10%, alpha equals 0.1. Okay, significant level, what we need to do in 10% significant level, do the data provide sufficient evidence to conclude that on average male have low error on detection than females. Okay, so we have 11 male and 11 female students, alpha is 0.1, so we have that information, and also they have given x1 bar which belongs to male population, and x2 belongs to female population. X1 bar means the mean of the male population, x2 bar is the mean of the female population, s1 is the sample male sample standard deviation, and s2 is the female sample standard deviation. They have given that. So first I'm going to explain how we calculate these values using critical value approach. So first step, define what is mu1. So my mu1 is the population mean error of male, mu2 is the population mean error of female. So hypothesis, my null hypothesis always mu1 minus mu2. So you should mention what is mu1 and mu2. That's what we have, that's what I have mentioned here. Okay, so alternative hypothesis, how we select the alternative hypothesis. Let me go back, and what we need to do, on average male have low error on detection than female. So male low error. So simply using that term you can identify what they ask. What they ask goes to the alternative hypothesis. Okay, so low error, which means mu1 less than mu2. Because of low error, they ask something about low error. Okay, so always what they ask go to the alternative hypothesis. H naught always mu1 equals mu2. Step 2, what is alpha? 0.1. Now we can calculate. First, we don't know what is the sigma, so we have to use the pooled standard deviation. So use this formula I showed you in few slides back. N1, you know what is N1, you know what is N2, S1 given, S2 given, so N and N2 know. So plug the values and get the standard, get the SP, pooled standard deviation. So it is 43.68. Okay, so test statistic, it is x1 bar minus x2 bar divided by SP times 1 over n1 plus 1 over n2. So you can simply plug the values. Okay, plug the values, and you have to simplify a little bit. Use your graphing calculators. I got here answer is for test statistic. Test statistic value is negative 0.9772. Okay, you can calculate that value. Now critical value. So degree of freedom, now we have to find the degree of freedom. It is n1 plus n2 minus 2, which mean 20. So here you have your alpha and your degree of freedom 20. Since you have both values, you can go to the table and find you can go to the T table and find the particular value. Since we have since our alternative hypothesis is less than, which mean left tail, our critical value is always negative value. Okay, we don't have negative value in T table. We have to consider that value is negative or positive using its tail, side of its tail. So since we have left tail, that critical value always negative. So how do we find this T value, T table value? So we have alpha equals 0.1, degree of freedom is 20. Okay, so in T table, by using first column, find the 20. Okay, first column find the 20, and in the columns you can find 0.1, 0.05, 0.005, something like that. So find these two and get the value. Okay, let me yes, I have T table. So alpha is 0.1, yes, degree of freedom is 20. So degree of freedom, see degree of freedom 20, it is here, and alpha 0.1, see, so value is this one. Clear? Value is 1.325. Okay, let me, okay, so value is 1 0.325. Why negative? Because we have left tail test. If you cannot find the degree of freedom in your t table, try to approximate, okay, closest degree of freedom. But don't worry, in the exam you can find your degree of freedom in the table, but in any case if you cannot find, try to approximate. Okay, so now this is our test statistic value, and this is our let me check. Okay, test statistic value, yes, 0.997, yes, and t value, table value is negative 1.32. So now what we can do, what we can say, negative 0.977, which means t value or test statistic value greater than this table value. So we can say we do not reject H naught. Okay, we do not reject H naught at 10% significant level. We can say further, at 10% significant level, we do not have enough evidence to say that sorry, on average male have low error on detection than female. Okay, so our test statistic value is greater than the table value, so it is outside the rejection region. So we have to like, do not reject H naught. We cannot reject the H naught, but we cannot say we accept alternative hypothesis. Okay, we never say like that. We simply say we reject H naught or we do not reject H naught. Okay. Okay. Now see how we get the same results using p-value. If you used critical value approach or p-value approach, it doesn't matter, you will get the same answer at the end. Okay, first few steps are very similar. We have to define our mu1 and mu2, then your hypothesis, alternative hypothesis, and then alpha. You have to figure out what is alpha. It is 0.1. Then plug the values to this, plug the values to find the pool standard deviation, same value, and then plug the value to find the test statistic, same test statistic. Fourth step is to find the p-value. So first find the degree of freedom. This is n1, this is n2, n1 plus n2 minus 2, so it is 2nd. So this is left tail test. Okay, this is left tail test because mu1 less than mu2, so left tail, something like this. P-value is greater than 0.1. Why? Okay, I'll tell you why. Degree of freedom is 20. Okay, degree of freedom is 20, and the test statistic value, see, 0.9772, 0.977. Okay, degree of freedom is 20. Okay, your t value is 0.9772, something like that. Okay, so you can see here this value is 1.325, right hand side value is 1.725, and for this side values are increasing, right? Values are increasing, starting from 1.325, but our value is 0.977, which means less than this value. The smallest value we can find regarding with respect to degree of freedom 20 is 1.325, which belongs to t 0.1, which means alpha 0.1, but we need a value less than this value, which means somewhere here, but we don't have that value, so that we can assume, okay, our p value is less than this value, because we can see the pattern, values are increasing this side, which means values are decreasing this side. Okay, so our value is 0.97, somewhere left hand to this value, which mean my p value is less than 0. Sorry, not less than, greater than 0.1. Why? Because see, t is 0.1. If you go this side, you can see the alpha value 0.05, 0.25, 0.01. Okay, yeah, it is greater than, yes. See, it is these values are decreasing. Okay, this side it is decreasing. 0.5, sorry, 0.05, 0.025, 0.01, 0.005, it is decreasing. Okay, but if you come this side, left hand side, you can see values are increasing. Okay, so your p value is somewhere greater than 0.1. Okay, that's how we identify whether if we don't have that value. So p value is greater than 0.1. Okay, okay, then your p value greater than this value, so your test statistic value. So p value is greater than 0.1, p value is greater than your alpha. Okay, significant value. So we do not reject H naught, we cannot reject H naught. At 10% significant level, we have no enough evidence to say that on average male have low error on detection than female. Okay, this is the interpretation. Idea is greater than 0.1. That's why we decide this H naught, whether we reject or not. Okay, this p value greater than the given alpha, so we do not reject. Okay, confidence interval. This is very easy, since you know what is the how to find the test statistic. Simply we can do some few, not some, we can do few calculations and find this confidence interval. Okay, first we assume that same as the previous case, we have random samples are independent, we have normally distributed population or large enough samples. Population, we have equal populations, and standard deviation are same but unknown. Okay, so confidence interval of mu1 minus mu2 you can find out easily by interchanging and multiplying terms of the t mean standardized t. Okay, so you don't have to do that, we have given it for you, so simply you can use this formula. Okay, this will gives this formula gives you two values, lower value and another value which is the higher value. Okay, because this is a interval. Interval always has a lower value and upper value. Okay, so you will see, find 90% confidence interval for mean error for the previous example. So alpha 0.1, you have to get the alpha over 2, which means 0.05. So go to the t table and find alpha 0.05 and degree of freedom is 25, value is 1.725. Plug those values. Okay, you know what is this gonna be, mu1, not mu1, it should be x1. Okay, x1 bar, this is x2 bar, plus or minus 1.75 is the t value, t 0.05 comma 20, that value. 43 came from SP, this is your SP. Okay, this is your 1 over n1, this is your 1 over n1, this is 1 over n2. So plug these values and get the answer. Yeah, it's here. See, negative 18.2 and 13.93. So your uh, interval is negative 18.2 to 13.93. So this is the interval. 90% confidence interval from mean error difference for male and female is this much. Okay, so I think this is the end of this yes chapter. In this chapter we discussed how to find the how to use the inferential by using critical value approach and p-value approach. At the end we found confidence interval. Okay, so for the confidence interval, please try to understand the formula, then you can apply that formula. No need to worry about how we develop this formula and so on. So just focused on plug the values to the particular formula and do your calculation. I know there may be little bit more work you have to do, you have to calculate, but try to use your calculator and get the values. Okay, okay, see you soon.